Welcome to Soft Science, where we explore the mysteries of the universe in a gentle and calming way. A place where your mind can wander slowly and your body can begin to relax. Where science becomes soft and curiosity can settle into calm. Tonight, we'll drift into the strange and beautiful world of quantum physics. A place where the rules of ordinary reality begin to blur. Where particles behave like waves, where things exist in multiple places at once, and where just watching something can change what it is. This is not the physics of falling apples or spinning planets. It's not the world of cars and clocks and coffee mugs. It's something much smaller and much more mysterious. This is the world beneath the atom, the subatomic world, the quantum world. And while it may sound complicated, we'll take it slowly. We'll let it unfold like a quiet story. One strange truth at a time. For hundreds of years, scientists believed the universe worked like a giant machine. This idea was known as classical physics, and it was led by one of the most brilliant minds in science, Isaac Newton. Newton's world was predictable. If you knew where something was and how fast it was moving, you could calculate exactly where it would go next. A baseball in flight, a moon in orbit, a pendulum swinging from side to side. Everything could be explained with precision. The universe was like a vast clock, mechanical, logical, and orderly. And for a long time, this worked. It explained almost everything, from the tides to the stars. But then, scientists started looking closer, much closer. They peered into the tiniest parts of matter, into atoms, and then into the particles that made up those atoms. And what they found didn't follow Newton's rules at all. It was as if the universe had a second layer, a hidden side. That didn't behave like the world we see. In this hidden world, particles didn't always have a clear position. They didn't move in predictable paths. They could jump, or appear, or vanish, and sometimes they could be in more than one place at the same time. This wasn't a mistake. It wasn't a flaw in the math. It was something new, something real, and it changed everything. The first person to truly unlock this hidden world was Max Planck, a quiet, thoughtful German physicist. In the year 1900, he was studying something known as black-body radiation. It sounds complicated, but it's really just about how things glow when they get hot, like a stove burner turning red, or the sun pouring out light. But when scientists tried to explain this glow using classical physics, it didn't work. The equations led to strange results, even infinities. So Planck tried something bold. What if energy wasn't continuous? What if it came in tiny, indivisible pieces? Little energy packets. He called them quanta. At first, it was just a trick to make the math work. But this little trick opened the door to a new understanding of reality, an understanding that would become quantum physics. Planck's idea was bold, but it was Albert Einstein who took it further. In 1905, Einstein studied a puzzling phenomenon called the photoelectric effect. When light shines on certain metals, it knocks out electrons. Tiny pieces of the metal get ejected just from the light. But here's the strange part. Brighter light didn't always do the trick. Only specific colors of light, or more accurately, specific frequencies, would cause the effect. This made no sense if light was just a wave, so Einstein made a radical proposal. What if light was made of particles? He said light comes in little bundles of energy, and each one is called a photon. If the photon has enough energy, it can knock an electron loose. If it doesn't matter how many photons there are. The electrons stay put. This was the beginning of something called wave-particle duality, and it's one of the strangest truths in all of science. Because light is both a wave and a particle at the same time, and it gets even stranger. Electrons, which we normally think of as particles, also behave like waves. And not just electrons. Everything does, even atoms, even molecules, even you. At the quantum level, everything has a wave-like nature, a quiet vibration beneath the surface, a kind of shimmering probability, and one experiment shows this more clearly than any other. Imagine a flat wall with two narrow slits in it. Behind the wall is a screen that can catch particles. Now, you shine a beam of light through the slits. What happens? You get an interference pattern, bands of light and dark, just like you'd expect from waves. The waves spread out, go through both slits, and interfere with each other. Now, here's the twist. You send electrons through the same setup, one at a time, little particles, fired like tiny bullets. But when you look at the screen, you get the same interference pattern, as if each electron went through both slits, as if each one interfered with itself. That shouldn't be possible, but it is. And here's the most mysterious part. If you try to watch which slit the electron goes through, if you place a detector at the slits, the pattern disappears. Just watching changes the result. The electron no longer behaves like a wave. It behaves like a particle again. One slit, one path. It's as if the act of observing forces the electron to choose. Before the measurement, it exists in a state of possibility, a kind of blurry cloud of outcomes. After the measurement, it collapses into a single reality. This is the essence of quantum physics. At its heart, it's about probabilities, not certainties, about clouds of potential rather than hard lines. It's not that the particle is hiding from us, it's that it truly does not have a defined state until we measure it. This idea became known as the observer effect, and it opened up deep philosophical questions. Does reality exist on its own, or does our observation, our consciousness, play a role in shaping it? In quantum physics, reality seems fluid, shifting, not locked down until something or someone observes it. It's not magic, it's not imagination. It's science. Tested again and again, confirmed in labs around the world. And yet, it's so different from the world we experience every day. So quiet, so strange, so dreamlike. And as you lie here now, soft and still, know that this world of uncertainty is not far away. It's within you, in your cells, in your atoms, in the particles that make up your body. Even as you rest, your electrons are dancing, your molecules are vibrating, your quantum field is alive. You are not separate from this strange world. You are made of it. Everything around you, the air, the walls, the stars beyond the sky, all of it hums with quantum possibility. Reality is not fixed, it's not rigid, it's not as simple as it seems. It's more like a whisper, a shimmering potential, a quiet unfolding of probabilities. And maybe that's why it feels so calming to know that beneath the surface, everything is soft, everything is open, everything is still being written. Let yourself breathe that in and let it carry you, ever so gently, deeper into rest. If everything is made of probabilities, If particles can be waves, and waves can be particles, then how does anything stay solid? How do we touch the world, walk on the ground, hold a warm cup in our hands if everything is uncertain? It's a quiet mystery. At the quantum level, nothing is ever perfectly still. Even in absolute darkness, even at temperatures near absolute zero, particles still wiggle, still vibrate, still move. This subtle motion is called quantum fluctuation. It's the gentle hum of existence, the background whisper of reality. And yet, from this uncertain, buzzing foundation, emerges the solid world we know. The world of stones and stars, of hands and houses, of trees growing in silence. The way this happens begins with something known as the wave function. The wave function isn't a thing you can see or touch. It's a mathematical expression, a quiet equation that tells us the probability of finding a particle in a particular place, or with a particular energy, or moving in a particular direction. It's like a soft map of possibility, a cloud of all the things that could happen. But when we measure the system, when we look, the wave function seems to collapse. All those possibilities become one, a single outcome. Where before there was maybe, now there is here, now there is real. It's as if the universe chooses, but only when it must, only when we ask. This raises a strange question. What is the wave function really? Is it a description of our knowledge, just a tool for prediction, or is it something real as gravity or light? This question has puzzled scientists for over a century. Some believe the wave function is just a way of managing what we don't know, that quantum physics is about information, not reality. Others believe the wave function itself is reality, that what's truly out there is the cloud, the possibility, the potential, until it collapses. And still others think maybe there is no collapse at all, that all outcomes happen every time. This is the beginning of the idea known as the many worlds interpretation. Imagine a simple event like flipping a coin, heads or tails. In the world you experience, you get one outcome, maybe heads. But what if, at the quantum level, both outcomes happened and the universe split? One version of you sees heads, the other sees tails, and both versions are real. This is what the many worlds interpretation proposes, that every quantum event causes the universe to branch. Again and again, endlessly. Not just metaphorically, but literally. A vast and silent branching of reality, each one as real as the last, each one following its own path. It's not something we can see or test directly, at least not yet, but it explains some of quantum physics' strangest puzzles, without needing the wave function to collapse. It simply keeps expanding, endlessly unfolding, forever. And while it may sound like science fiction, this interpretation is taken seriously by many physicists, because it matches the math, it follows the rules, and it fits. Still, not everyone agrees. Quantum physics is full of interpretations, each one trying to make sense of the same experiments, the same results, but each one paints a different picture. Some believe in hidden variables, that the particle always had a path, we just couldn't see it. Others say randomness is truly built in, that nature itself is uncertain, that chance is real. And some, like Niels Bohr and the Copenhagen school, say it's best not to ask what's really happening at all. They say, don't try to picture it, just use the equations. They work, that's enough. But humans are curious. We want more than math. We want meaning. We want to know what kind of world we live in. A world of chance, a world of choice, a world of branching timelines and infinite realities. Quantum physics doesn't settle the question, but it does offer something beautiful. It shows us that the universe is not simple, not mechanical, not predictable in the way we once thought. It's deeper than that, softer than that, and filled with mystery. Even empty space isn't truly empty. At the quantum level, the vacuum is alive. It bubbles with energy. Pairs of particles blink in and out of existence. Virtual particles born and gone in an instant, like tiny echoes, like ripples in a dream. This quantum foam may be the fabric of reality itself, the stage on which everything plays out, and it's everywhere, between your hands, in your breath, in the silence of space. Every atom in your body is part of this dance, a quiet choreography of uncertain motion, a delicate swirl of probability and form. Even light, the most familiar of things, behaves in strange ways. It travels at a constant speed, always, no matter where you are or how fast you move. This fact, just this one, breaks the rules of common sense, and it leads to time dilation, to mass increasing with speed, to energy becoming matter, all because of quantum principles merging with relativity in the deep structure of light. And yet, as strange as it is, it all fits together. The quantum world is not broken. It is not random chaos. It is just more subtle than we ever imagined. It is patterned, it is lawful, it is structured, but softly, like a web you can't quite see. The more you look, the more beautiful it becomes. Electrons orbiting in clouds, photons dancing between particles, fields rippling invisibly through space. These are not guesses, they are measured, confirmed, real. And through them, we've built lasers, transistors, computers, the modern world, all of it balanced on the edge of quantum reality, a dream made solid, a theory that works. So as you rest, know this: you are not separate from this strange world. You are made of it. You are a pattern in the field, a vibration in the fabric, a quantum event unfolding gently in time. And that's not poetry, it's physics. Your thoughts, your breath, your being, all arise from this soft, uncertain world. A world where particles shimmer between states, where choices ripple outward, where reality itself is still being written with every passing moment. Let that thought hold you, gently, softly, as you float deeper into stillness. There is nothing you need to solve, nothing to control, only wonder and the quiet joy of knowing the universe is more mysterious, more delicate, and more alive than we ever believed. There's something humbling about realizing we can never observe the quantum world directly. We can only infer, measure, interpret. It's a bit like trying to understand the ocean from a single droplet. You can sense the depth, but never quite grasp the whole. The instruments we use to explore quantum systems, telescopes, particle detectors, beams of light, are all part of the larger, classical world. And yet, every time we try to look more closely, we disturb what we're trying to measure. This is one of the central truths of quantum mechanics. It's called the uncertainty principle. Introduced by Werner Heisenberg in 1927, it tells us that there are certain pairs of things we simply cannot know at the same time. For example, the more precisely we know a particle's position, the less precisely we can know its momentum, and vice versa. It's not a limit of our tools, it's a limit built into reality itself. This uncertainty isn't a mistake. It's not noise in the system, it's the system. At the quantum level, things don't have definite values until we try to measure them. An electron doesn't have a precise location or speed until we ask it a question, and the very act of asking changes the answer. Heisenberg's principle isn't just about measurement, it's about nature, about the idea that reality is, at its core, a web of relationships, rather than fixed properties. Instead of imagining particles like tiny billiard balls, it might help to think of them as patterns, ripples, events, something that happens, rather than something that simply is. This shift in perspective is one of the great gifts of quantum thinking. It invites us to release our grip on certainty, to be comfortable with possibility, to embrace ambiguity not as a flaw, but as a feature. Imagine the atom. At school, we often learn that atoms are like miniature solar systems, with electrons orbiting a nucleus like planets around the sun. But this picture is deeply misleading. In truth, electrons don't orbit in neat circles. They don't follow defined paths. They exist in what we call orbitals, regions of space where the electron is likely to be found. It's not that the electron is in one spot and we just don't know where. It's that the electron is genuinely spread out. Like a cloud, a probability distribution, a presence, not a point. These orbitals form beautiful shapes, spheres, dumbbells, rings, all described by the equations of quantum mechanics, each one corresponding to a specific energy level, a specific vibration in the field, and as electrons shift between these levels, they absorb or release photons, tiny packets of light. This is how atoms interact with the world, how they absorb energy, how they shine. It's how we get color, light, chemistry, life, all from electrons moving, not along paths, but across possibilities. Now consider something else. Entanglement. Perhaps the strangest and most beautiful phenomenon in all of physics. When two particles become entangled, their states are no longer independent. Measuring one instantly affects the other, no matter how far apart they are. You could separate two entangled particles by 1,000 miles, and yet, when you observe one, the other knows. Einstein called this spooky action at a distance. He didn't like it. He thought there had to be a hidden mechanism, some secret communication beneath the surface. But every experiment has confirmed it. Entanglement is real, and it defies classical explanation. It tells us something profound, that particles are not truly separate, that the universe is, at its core, deeply interconnected, not just metaphorically, but physically, mathematically. What happens in one place is linked to what happens in another. Entanglement is now being used in cutting-edge technologies, like quantum computing and quantum encryption. But even beyond its applications, it holds a quiet truth. That separateness may be an illusion, that the fabric of reality is woven together. When we let that idea settle in, it changes something. The boundaries between self and other begin to soften. We realize that we're not isolated observers looking out at a fixed world. We're part of the dance, entangled with it, shaped by it. Even your thoughts, your feelings, your dreams arise from the quantum nature of your brain. Neurons firing, molecules interacting, waves of electrochemical possibility. Some scientists even wonder whether the consciousness itself might be rooted in quantum phenomena. That the mind, like matter, is both wave and particle, both potential and collapse. It's not proven, not yet, but it's a beautiful idea that perhaps awareness arises from the same strange rules that govern electrons and photons, that maybe we are, in some deep way, a quantum system, experiencing itself. And if that's true, then each thought, each moment of presence is a kind of quantum event, a point of emergence, a ripple in the field, not separate from the universe, but an expression of it. Everything we see, every star, every cell, every spark of intuition has its roots in this invisible world, a world where matter and energy blur, where observation shapes reality, where uncertainty is law, and still, it all works. The mathematics of quantum theory is among the most accurate in all of science. We can use it to predict the behavior of particles to more than 10 decimal places. We use it to design electronics, to build lasers, to measure time with atomic precision. It's not just abstract, it's practical, it works. And yet, it resists our intuition, because the quantum world doesn't care about what we expect. It simply is. It doesn't need to make sense. It only needs to be consistent, and it is. Every time we ask, it answers. Not always with clarity, but always with precision. That in itself is a kind of comfort. To know that beneath all the mystery, there is structure. Beneath the strangeness, there is symmetry. Beneath the uncertainty, a deeper harmony. So as you lie here, soft and still, know that your body is not solid in the way it seems. You are a lattice of particles, a cloud of probabilities, a humming collection of fields. Your skin, your breath, your heart, all dancing at the edge of uncertainty. You are quantum, and that doesn't make you smaller, it makes you vast, because the quantum world is not somewhere far away. It is here, now, within you. It is the reason you can think, the reason you can dream, the reason you can rest. It's the rhythm behind every breath, the silence between every heartbeat, the stillness within motion, and as you drift into sleep, you are not disappearing from the world, you are returning to it, merging again with the field, with the fabric, with the wave. You don't need to understand it all. You don't need to solve it. Just feel it. The softness, the mystery, the quiet presence of a universe, whispering its secrets. Not in words, but in possibility. There's a beauty in knowing the rules of quantum physics don't break. They simply go deeper. The more closely we look, the more the universe reveals layers we never expected, each one stranger and more elegant than the last. We tend to think of reality as made of things, objects, matter, stuff. But quantum physics teaches us something different. That reality is made of fields. In modern physics, the fundamental ingredients of the universe aren't particles. They're quantum fields. Invisible, continuous energy fields that fill all of space. Every type of particle, electrons, photons, quarks, is just a ripple in its corresponding field. The electron you've heard of isn't a tiny marble floating in space. It's a small excitation in the electron field. The photon, the particle of light, is a ripple in the electromagnetic field. The Higgs boson is a ripple in the Higgs field. In other words, particles aren't separate from space. They are space, shaped into specific vibrating forms, like waves rising from the surface of a pond. And you are a constellation of those waves. patterns forming patterns, a collection of ripples, aware of itself. Quantum field theory is the framework we use to describe this. It's complex, mathematical, but at its heart is something gentle. That space isn't empty, it's alive. Every point in space holds potential. Every ripple is an event in that field. Fields create particles. Particles create matter. Matter creates life. And life looks back at the fields and wonders. Even time in the quantum world is not what it seems. We experience time as a steady flow, a line from past to present to future. But on the quantum level, time behaves differently. Some equations don't even require time to exist. They're timeless, symmetric, where the flow of time is not a fundamental feature, but an emergent one. Some interpretations suggest that time arises from entanglement, that what we call now is a local experience, a kind of synchronization within a web of quantum events. If that sounds strange, that's okay. You don't need to grasp every detail, just let the idea settle, let it drift. The flow of time may not be as absolute as we think, and this opens new doors, not just in physics, but in how we see ourselves. Because if time is not fixed, if past and future are not rigid walls, then maybe choice is real. Maybe the present moment truly matters. Quantum theory supports this idea in a subtle way. Unlike classical systems, quantum systems don't unfold with total predictability. They branch, they evolve based on probabilities. And the observer, your presence, can influence what outcome becomes real. This doesn't mean you control the universe, but it may mean you participate in it more deeply than you realize. It's not about power, it's about connection. At the quantum level, every interaction is a relationship. A measurement is not just a reading, it's a handshake, an entanglement, a moment where two things become one system. When you observe something, you are not just gathering data, you are becoming involved. You are shaping the outcome. Even in the most sterile labs, even in the quietest atoms, this holds true. And that gives new meaning to awareness, to attention, to being here now. There's another beautiful example of this in the concept of quantum superposition. In the quantum world, a particle doesn't exist in just one state. It exists in a combination of all possible states at once. Imagine a coin spinning in the air. Is it heads or tails? In the classical world, we'd say it has one true value. We just haven't seen it yet. But in the quantum world, before measurement, the coin is both. Heads and tails, every possibility, layered together. Only when you observe it does the superposition collapse into a single result. This is more than a metaphor. It's a core principle of how particles behave. One of the most famous thought experiments in physics, the Schrödinger's cat experiment, was designed to show how strange this really is. Imagine a sealed box with a cat inside. Also inside the box is a mechanism that depends on the decay of a radioactive atom, a quantum event. If the atom decays, the mechanism releases poison and the cat dies. If it doesn't, the cat lives. But until you open the box, until you observe the system, the cat is in a superposition of states, both alive and dead, both possibilities entangled with the atom. This isn't about cats or cruelty. It's about the absurdity of applying quantum rules to large objects. But increasingly, experiments show that superposition isn't just theoretical. We've seen atoms, molecules, even clusters of molecules, exist in superpositions. We've watched them interfere with themselves, act as though they're in multiple places, multiple states. And it raises a question. Where does superposition end? At what scale does the classical world begin? We don't fully know. The line between the quantum and the everyday is blurry, soft, mysterious. It may be that the boundary doesn't really exist at all, that the classical world is simply quantum averaged out, that what we call normal reality is just what happens when billions of superpositions blur together. And if that's true, then the strange rules of quantum physics aren't confined to tiny particles. They apply to everything, even you, even now. The air in your lungs, the light in your room, the warmth in your skin, all of it, rippling fields, superpositions, entanglements, quiet events unfolding just beneath awareness. And yet, it doesn't feel strange, it feels familiar, because we live in it. You don't need to understand the math to feel the presence of this deeper world. You don't need a lab, you don't need a telescope, you only need silence, curiosity, a moment of stillness. That's where the quantum world becomes real, not in complexity, but in simplicity. In the breath you just took, in the gentle fact of being alive. So tonight, as you drift into sleep, let yourself imagine the world beneath the world. A universe not of things, but of patterns. Not of solid matter, but of probabilities. Not of fixed paths, but of possibilities. Let yourself become soft, like the wave, like the field. Let go of needing to know, and simply feel. You are not apart from the quantum world. You are it.
A ripple in the field, a breath in the equation, a mystery wrapped in gentle awareness.
Sleep in that knowing, somewhere in the quiet fabric of the universe. There is a limit to how small we can go, a boundary beneath which space and time may no longer behave the way we expect. This is the Planck scale. Named after physicist Max Planck, this scale defines the smallest meaningful units of space and time. The Planck length is unimaginably small, about 1/10,000,000th of a trillionth of a trillionth of a centimetre. At that scale, space may not be smooth, it may be grainy, foamy, irregular, and time too may not flow like a river, but tick like a clock, in discrete quantum steps. We can't observe the Planck scale directly, not yet, but the mathematics suggests that reality may have a foundation that is not continuous but quantized. Just like energy, just like light. This gives rise to an idea both strange and beautiful, that space and time themselves may be made of something, not made of matter, but made of relations, connections, information. Some physicists believe that space-time emerges from something deeper, from a network of quantum entanglement. Imagine space not as a container, but as a pattern, a tapestry of links, each point in space connected to others by quantum relationships. This view changes everything. It suggests that what we call here and there are not fixed distances, but degrees of entanglement. That location is defined not by coordinates, but by how deeply things are linked. This is what some call emergent space-time. Not a stage the universe plays on, but something the universe builds from within, like a spider spinning its own web. In this view, gravity itself may be a consequence, not a cause, a result of the way information is organized across the quantum field. And your body, your mind, your sense of place, all ripple across this field. The more we look at the quantum world, the more it reflects ideas that seem almost philosophical. Ideas like complementarity. This principle, introduced by Niels Bohr, tells us that quantum systems can exhibit different, seemingly contradictory properties, but never at the same time. Light can behave like a particle or a wave, but not both at once. It's not that light switches between forms, it's that the form you see depends on how you choose to observe it. This isn't just about light, it's about the nature of knowledge. In the quantum world, some truths are mutually exclusive. To see one is to lose sight of the other. And this is not a flaw, it's a feature of the system. Reality at this level is not absolute, it is contextual, dependent on how and what we choose to observe. It's humbling and freeing because it means there is no single, complete view, no God's eye perspective, only perspectives linked by the rules of quantum mathematics. And this too mirrors the way we live. Every relationship you have, every conversation is shaped by context, by what is asked, by how it is seen. There is no final answer to who you are, only expressions, only unfoldings, only patterns in motion. Another subtle truth of the quantum world lies in decoherence. This is what happens when a quantum system interacts with its environment, when it becomes entangled with the world around it. The system loses its superposition, not because it was observed in the usual sense, but because it becomes part of a larger web. The wave function doesn't collapse, it spreads. This is one way to explain why we don't see superpositions in daily life, why we don't observe people being in two places at once, or cats that are both alive and not. Because we are already entangled, already part of a vast, open system. And in that openness comes classical reality, the world as we know it. But beneath that world, the wave still hums. Nothing ever truly collapses. It simply shifts, expands, dissolves into the greater pattern. This might sound abstract, but it's happening around you and within you all the time. Your brain is a quantum system, but it is also a warm, noisy environment. Its quantum features are hard to detect, but not impossible. Some researchers believe that consciousness could involve quantum coherence, brief windows where quantum information remains intact before decoherence sets in. Others are cautious. The brain is complex, and we are only beginning to understand how mind and matter relate. Still, the possibility remains that consciousness and quantum physics are not separate domains, but echoes of the same mystery. That awareness, like energy, can be subtle, fleeting, but real. And that brings us to another beautiful truth. In quantum theory, energy is never truly lost. It changes form. It moves through systems. It may seem to disappear, but it always leaves a trace. This principle, known as conservation of energy, holds even in the strangest corners of physics. And when paired with quantum tunneling, it paints a picture of the universe that is deeply hopeful. Tunneling is a process where a particle passes through a barrier it technically shouldn't be able to cross. Classically, it doesn't have enough energy, but in the quantum world, there is always a probability, always a chance, and sometimes that chance is enough. This is how stars ignite, how nuclear fusion begins, how particles move in biological systems, how life persists in the face of limits. Because in the quantum world, nothing is fully closed. No wall is truly solid. No path is entirely blocked. There is always a softness, a possibility, a thread of light weaving through the dark. You are that thread. You are made of the same particles that tunnel, the same fields that ripple, the same possibilities that never vanish. And that means your life is not fixed, not mechanical, not predetermined. It is quantum, it is open, and it unfolds, moment by moment, through a series of interactions, through choices, through attention, through stillness. So as you rest tonight, know that you are not held by certainty, but by motion, by laws that are fluid yet precise, by a universe that whispers not in facts, but in potentials. You don't need to hold it all. You don't need to understand every equation. You are already part of it. You are a question the universe is still asking, a wave still rising, a soft, entangled light, glowing quietly in the field. Sleep now, in the warmth of that knowing. Let the wave carry you deeper. There is nothing you need to do. Only drift. Only breathe. Only be. There's a quiet rhythm to the quantum world. Beneath the formulas and measurements, beneath the strange behavior and paradoxes, is a sense of deep harmony. Not noise, not chaos, but music. Particles vibrate at precise frequencies. Fields resonate with specific energies. Every interaction, every transition, every shift from one state to another follows a pattern. It's called quantization. In the quantum world, energy doesn't flow like water. It comes in steps, discrete packets, units. Whether it's the light of a star, the orbit of an electron, or the heat in your hands, it all moves in quanta. This is what Max Planck discovered when he studied black-body radiation, how objects glow with heat. To make the equations work, he had to assume that energy was not continuous, but came in tiny chunks. Quanta. And in doing so, he opened the door to everything that followed. Einstein used this idea to explain the photoelectric effect, how light can knock electrons off metal. He proposed that light wasn't just a wave, but a particle, a photon, a quantum of electromagnetic energy. That insight earned him the Nobel Prize, and it showed that the universe behaves in a dual way. Waves can act like particles, particles can act like waves. Everything is both. This is known as wave-particle duality. It's not a metaphor, it's a fact. Electrons, when not observed, spread out like waves, but when we detect them, they arrive as single points, like dots of matter. Photons interfere with themselves. They create patterns on screens that no single particle could explain, but we only see that pattern when we stop measuring and start watching. It's a kind of cosmic dance. The more you try to catch it, the more it slips away. But when you soften your gaze, it reveals its full shape. This dance shows up most clearly in the double-slit experiment. Imagine shining light through two narrow slits onto a screen. If light were a particle, it would pass through one slit or the other, creating two bright spots. But that's not what happens. Instead, the light creates an interference pattern, dark and bright bands, the kind of pattern only waves create. Now try it with one photon at a time. Still, the pattern forms. Each photon seems to interfere with itself, as if it travels both paths at once, as if it's in multiple places, until we observe it. And if we try to measure which slit it goes through, the interference disappears. The wave becomes a particle. The pattern collapses. This experiment has been repeated with electrons, with atoms, even with molecules made of hundreds of particles, and the result is always the same. The world behaves like a wave, until we look. Then it becomes a point, and the question lingers. What causes the collapse? Is it the act of observation, the presence of a conscious mind, the interaction with a measuring device? No one knows for sure, but the mystery remains that everything we see arises from something we don't see. A deeper structure, a field of potential, and the act of looking brings it into form. There's something deeply human about this, not in a way that puts us at the center of the universe, but in a way that says we are not separate from it. Our presence matters. Our attention shapes the world. This is not superstition, it's physics. And yet it has spiritual echoes, because it reminds us that the universe is not a machine running without us. It's a field we participate in, a wave we ride. Some scientists push this even further. They ask, what if the universe itself is a kind of quantum computer? A system evolving through quantum states, processing information, following simple rules that give rise to incredible complexity. In this view, reality is not made of stuff, but of bits. Not classical bits, ones and zeros, but quantum bits or qubits. Qubits are the building blocks of quantum computing. Unlike classical bits, which can be in one state at a time, qubits can exist in superposition, both 0 and 1 at once, and they can be entangled, meaning their states are linked, no matter how far apart. With these properties, quantum computers can solve certain problems that classical computers cannot. They can simulate molecules, factor large numbers, search massive databases. But more than that, they may mirror the logic of the universe itself. Every particle interaction, every moment of time, every event could be a kind of computation, not deterministic, but probabilistic, not rigid, but evolving. This doesn't reduce the universe to numbers. It expands our view of what computation can mean. It means the universe is not dead. It's active, responsive, flowing, like a mind, like a breath, like a song. And we are part of the song. Each of us is made of qubits, fields, vibrations, information, our bodies, our thoughts, our memories, all of them entangled. Not metaphorically, literally. Your atoms are entangled with those of stars, with particles formed in the early universe, with light that crossed billions of years to reach your eyes. You are not just in the universe, you are of it. You are the field folding in on itself. When we look at the quantum world, we're not just studying something out there, we're studying ourselves, our source, our structure, our potential, and it brings us to a quiet truth. That reality is not fixed. It is participatory. The outcome is not written until the moment arrives. The path is not set until we walk it, and that includes your life. Your future is not a script, it's a superposition, a cloud of possible realities, and every thought, every intention, every step brings one path into being. This isn't magic, it's physics, and it gives you space to breathe, to be soft with yourself, to know that you're not here by accident. You are a result of entanglements stretching back to the dawn of time. You are a point of coherence in a universe of waves. So as you close your eyes, let go of the need to be certain. Let go of the idea that you must figure everything out. You don't have to collapse every wave. You are allowed to remain open. You are allowed to rest in possibility. You are allowed to just be. The quantum world holds you, not tightly, but gently, not with answers, but with presence. Sleep in that presence, and let the waves carry you. Quantum physics often challenges the way we think about cause and effect. In our everyday world, causes lead to effects in a clear order. One thing happens, then another. But at the quantum level, this sequence is not always so simple. Particles can be connected in ways that seem to bypass time itself. Events can be correlated without a clear cause or effect. This phenomenon is called quantum non-locality. Non-locality means that two particles, no matter how far apart, can influence each other instantly. This defies our usual ideas about space and time, where information cannot travel faster than the speed of light. Yet experiments show that entangled particles respond to each other's states immediately, as if linked by an invisible thread. This doesn't mean information travels faster than light, but that the concept of separation itself breaks down at the quantum level. It suggests a deeper unity, a universe where distance and separation are not fundamental, where everything is connected through a hidden web. This idea echoes ancient philosophies of oneness and interconnection, yet it arises from the most rigorous scientific experiments. Another mind-bending aspect of quantum theory is the idea that particles do not have definite properties until measured. This is known as the principle of superposition. It's as if reality holds multiple possibilities simultaneously, a cloud of potential states. Only when an observation is made does this cloud collapse into a definite outcome. This collapse is mysterious. It raises questions about what constitutes an observation. Does it require consciousness, or is any interaction with the environment enough? Theories differ, and the answer remains open. Some interpretations suggest that consciousness plays a key role in collapsing the wave function. This idea, sometimes called the consciousness causes collapse hypothesis, proposes a profound link between mind and matter. While controversial, it invites us to consider the possibility that our awareness participates in shaping reality. Others prefer interpretations that do not require consciousness, such as decoherence theory. Decoherence explains that interactions with the environment effectively select outcomes, causing the superposition to appear collapsed. This is why the classical world seems definite, even though underlying quantum systems remain in superposition. Both views acknowledge a subtle boundary between potential and actual, between what could be and what is. In this way, quantum physics reveals a universe that is not fixed and deterministic, but fluid and open. Possibility dances with reality. Potential folds into form. This invites a gentle acceptance of uncertainty, a release of rigid expectations, a surrender to the unfolding mystery. Even in the complex mathematics of quantum field theory, elegance emerges. Equations describing particles and forces fit together like a cosmic puzzle. Symmetries and invariances guide the behavior of everything from the smallest quark to the largest galaxy. These symmetries tell us that the laws of physics do not depend on where we are or when we are. They remain constant, universal, unchanging. This constancy provides a deep sense of order beneath the apparent chaos. And within this order lies creativity. Quantum fluctuations give rise to new particles, new events, new realities. From these fluctuations, the universe breathes and evolves. The early universe itself began as a quantum fluctuation, a tiny, unstable state, that expanded rapidly in the Big Bang. From that seed grew stars, planets, life, and consciousness. You and I are the descendants of this quantum dance, made of the same ripples and vibrations, embodied waves of probability brought into form. As you listen now, you are part of this unfolding. Your breath, your heartbeat, your thoughts all resonate with the quantum world. The mystery of quantum physics is not distant, it is within you, within everything. It invites you to soften your gaze, to rest in wonder, to embrace the unknown with curiosity rather than fear. So as you drift deeper into sleep, let the quantum world cradle you. Let the waves of possibility wash over you. Let the dance of particles and fields lull you into calm. You are a wave on the vast ocean of existence, both unique and connected, both transient and eternal. Sleep now in that knowing, in the gentle embrace of the strange and beautiful quantum world. Quantum physics doesn't just reveal the building blocks of matter, it also gives us insight into information itself. In the quantum realm, information is fundamental. It is not just a way to describe the world, but a physical quantity with real effects. This leads us to the concept of quantum information theory. It studies how information is stored, transmitted, and transformed at the quantum level. Unlike classical bits, quantum bits or qubits can exist in superposition, enabling new kinds of computation and communication. One remarkable feature of quantum information is quantum teleportation. Despite what science fiction suggests, this process doesn't transport matter instantly. Instead, it transfers the quantum state of a particle from one location to another, using entanglement and classical communication. Experiments have demonstrated teleportation of photons, atoms, and even small groups of particles over significant distances. This opens pathways to secure quantum communication and revolutionary technologies. Quantum encryption, for example, uses principles like entanglement and uncertainty to create communication channels that are provably secure. Any attempt to eavesdrop changes the system and is immediately detected. This could transform cybersecurity in the near future. But quantum information theory also leads us to profound philosophical questions. What is reality if it is made of information? Could the universe itself be a vast quantum computer? These ideas suggest a reality constructed from bits of data processed through quantum laws. Some physicists propose the holographic principle, which imagines our three-dimensional world as encoded on a distant two-dimensional surface. Like a hologram, the full image appears with depth and detail, though the underlying information lies elsewhere. This challenges our intuitive sense of space and dimension. It hints that the universe is more like a vast information system than a collection of particles in space. Such ideas blend physics with philosophy. They ask us to reconsider what it means to exist, to observe, to be. You are both observer and participant in this grand information dance. Your consciousness may be entangled with the universe in ways we do not yet understand. This awareness invites a gentle humility and a profound awe. It calls you to rest softly in the unknown, to trust the unfolding, to embrace the mystery as a gift. As you prepare to drift further into sleep, remember that you are part of this strange and beautiful universe. You are a node in a cosmic network of information, energy, and possibility. You are quantum. You are light and shadow, wave and particle. You are the quiet observer of your own becoming. Let the subtle rhythms of the quantum world soothe you. Let the harmony of the universe cradle your mind. As we come to the close of this journey into the strange world of quantum physics, it's natural to feel a sense of awe. The universe we live in is not the simple, mechanical clockwork once imagined. Instead, it is a vast, dynamic tapestry woven from waves, particles, fields, and information. A tapestry alive with possibility and mystery. Quantum physics teaches us that at the heart of reality lies uncertainty, interconnectedness, and creativity. That the act of observation shapes what we see. That particles can be in many places at once until measured. That space and time themselves may be emergent, arising from deeper quantum relations. This knowledge invites us to rethink not only the cosmos, but ourselves. To understand that we are not isolated observers, but participants in a grand unfolding. That our thoughts, our awareness, and our presence matter. That the boundaries between self and world are more fluid than they appear. In this light, each breath becomes a quantum event, each moment a ripple in the universal field, each dream a superposition of possible realities. You are a living expression of the quantum universe, a beautiful wave in the infinite ocean of existence. As you lie here now, gently sinking into rest, allow these truths to wash over you. Release the need to control or fully comprehend. Embrace the wonder of not knowing. Find peace in the dance of uncertainty. Let the soft hum of quantum fields lull you deeper. Feel the gentle pulse of energy flowing through every part of you. Know that you are connected to the stars, to the earth, to all that ever was and ever will be.
The strange world of quantum physics is not distant or abstract. It is here. It is now. It is you.
So sleep well, sleep deeply, rest in the quiet mystery.
And when you awaken, carry with you the gentle knowledge that you are part of a universe more wondrous than words can capture.
Thank you for joining this journey into the strange and beautiful quantum realm. May your dreams be filled with light and possibility. Good night.